When the Raspberry Pi 5 was released, one of the most exciting things about it was the fact that it featured a PCI Express port. Now at the time, they didn't release any specifications about that port and how to use it, and this resulted in many, including myself, to be a little bit disappointed by that. However, back in December of 2023, the Raspberry Pi Foundation did release the specifications for the port. And indeed, we then saw Pimoroni release a base board for the Raspberry Pi 5 that you could install an M.2 SSD onto, and have that communicate with the Raspberry Pi through PCI Express. Now this was really brilliant, and it allowed Raspberry Pi users to access really speedy storage for the first time. But being able to attach NVMe storage is only one thing that you can do with PCI Express. Using an adapter such as this one, you could turn that M.2 socket into a regular PCI Express slot, as it gives you the means to connect all of these kinds of devices straight to your Raspberry Pi. Let's go and take a look. Hello once again, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. In my spare time, I love playing with Raspberry Pis. And another guy that does is Chris over at Explaining Computers. And Chris has put out the wonderful news this week that his channel has just reached 1 million subscribers. This is amazing, and many congratulations to Chris on that milestone. It just goes to show just how strong this tech community is, and I just wish Chris nothing but the best for the future, and I hope his channel just continues to grow. Now, if you like what you see here, please click that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Also, let me know in the comments what your favourite Pi projects are. And if you've got any ideas for projects that you'd like to see me do, put those in there as well. This time, I'm going to be looking at actually attaching PCI Express devices directly to a Raspberry Pi. Now this is all thanks to the fact that when the Raspberry Pi 5 was released, it included a PCI Express slot. Now it took a little while before we started getting some devices that could make use of this, but one of them that came up was this one from Pimoroni, where we could attach an NVMe SSD straight to the Pi 5 using the PCI Express port. With all that put together, it looks something like this, where the board sits just below the Raspberry Pi and there's a little ribbon cable that connects the PCI Express port onto that board. Now I've got one set up with my Raspberry Pi 5 right now. In the top corner, you can see a live video of my Pi 5 running, along with the NVMe drive underneath. So if I execute the list block command, you can see the NVMe drive does show up there. And indeed, I can test its performance with the HD palm command. And here you can see that we achieved a read rate of 784 megabytes a second, or just under 6.3 gigabits per second. But how does that stack up compared to what the expectations are? Well, we can see that in this chart here. This shows all of the respective speeds that are expected through PCI Express slots based on different generations and the amount of lanes of PCI Express throughput available. Now the PCI Express slot on the Raspberry Pi 5 is only a single lane PCI Express, so it's only the leftmost column that we can read from here. Now the PCI Express slot on the Raspberry Pi natively only supports generation 2 of PCI Express. However, you can provide configuration to have it support generation 3. As a result, these are the speeds that are available to us. If we're running in generation 2, then we can only expect up to around 4 gigabits per second. If we're running generation 3, then we could expect just under 8 gigabits per second. So the fact that we measured 6.3 earlier is actually a pretty good result. It's not far away from what the maximum expected is for generation 3 with a single lane. And the fact that the Raspberry Pi is a single board computer and costs about £60, I think that's really good. Now of course, being able to attach NVMe storage to a Raspberry Pi is really cool, but it is a little bit limiting. I mean, there's more you can do with a PCI Express slot than add storage. And that's where this thing comes in. This is an NVMe to PCI Express port adapter. In a lot of ways, an M.2 slot is just a reformatted PCI Express 4-lane slot. And so it's actually quite straightforward to adapt that to a straight PCI Express socket. That's what this adapter does, and it's actually remarkably cheap. You can just plug that straight into the M.2 port of the Pimoroni NVMe board for the Pi 5, and then this allows you to attach any PCI Express device you want. Since there's only one lane of PCI Express available and it's limited to Generation 2 and Generation 3, this does put some limitations onto the cards that we can actually attach to it. But as long as we don't go crazy, things should work out alright. Now let's get the adapter set up, and then let's try out plugging in some PCI cards and see what happens. Here, you can see that I've flipped the Pimoroni NVMe Base around onto its back, so it actually sits on top of the Raspberry Pi now. This allows the M.2 slot to actually be on the top of the device. Now this does of course mean that the Pi 5's fan is blowing directly onto the bottom of the NVMe base, but so long as I don't put all of this into a case, it should be absolutely fine in terms of airflow. I've attached the M.2 to PCI Express adapter into the M.2 slot, and I'm providing power to it using an external hard drive power brick. This can provide up to about 36 watts, so it should be plenty for what we want to do here. Now natively, PCI Express in a regular PC could consume about 75 watts from the host computer, so we're definitely going to be down on power, but again, unless we try to plug in a high power device, it shouldn't actually affect anything. So now let's go ahead and plug in a PCI Express card and let's see what happens. The first card that I'm testing here is a USB expansion card. Now this should add 4 more USB 3 ports to the Raspberry Pi. Now these can't all provide the USB connectivity at full speed, and that's because of this. This card will provide USB 3.0 speeds, so that's shown as 5 gigabits per second. And if you remember back to our PCI Express speeds, the highest throughput we could get there was 7.88. So given this particular card has 4 ports on it, the only way we can get full speed for USB 3.0 is by using one device at a time, and that should be able to run at its full 5 gigabits a second. If we plugged in more USB devices, then that available bandwidth, that 7.88 gigabits per second, would be shared between all of the ports, so you'd see the effective bandwidth go down. But just to test this, I'll plug in a USB NVMe adapter. This will have the same SSD drive installed in it as we used directly on the NVMe Pi 5 adapter I showed earlier. We should see it not run quite as fast because the USB 3.0 port will only allow a maximum of 5 gigabits per second. But let's see how we get on. Here, in the top left, you can see my Raspberry Pi with its PCI Express card plugged in. On the right, you can see the desktop of the Raspberry Pi. The first thing I'm going to do is run the command lspci-k to show us what PCI devices are attached. And here, you can indeed see that our USB 3 controller board is connected. Since it's been recognised, we should also have a new block device recognised, which is the NVMe storage connected to the USB PCI Express card. And indeed, there you can see it labelled as SDA1. Now let's test the performance to it. As you can see, the performance that we've got is now down at 368 megabytes a second. And while this is a little bit low, I was expecting something a bit closer to 5 gigabits per second. This works out to roughly 3. But you can see that everything does still work very nicely. And I've not had to do anything specifically with the Pi 5 in order to get it to work alongside this PCI Express card. So it's off to a really good start. The next thing I'm going to try here is something a bit more ambitious, a Wi-Fi 6E card. Let's see how well that gets on. Here, you can see that I've got the card connected onto the Raspberry Pi, but before we can actually make use of it, there's a couple of things that I need to do first. Now, by default, the Raspberry Pi operating system doesn't ship with the firmware required for this card. Other Linux distributions would ship with it, but we can install it. Now we've got the firmware installed. The other problem is that the actual kernel drivers for the card aren't included in Raspberry Pi OS, so we need to build a custom kernel. Now this probably sounds really complex and horrible, but it's actually quite simple. The first thing you have to do is grab all the kernel source code from GitHub. In this case, I'm going to grab the most recent 6.7 experimental build from GitHub. The reason for this is that it'll allow the most recent firmware for this network card to be used. Once all of that is downloaded, there are a series of commands that you have to run in order to build your kernel. Now I've wrapped all of these up into a little shell script, so I don't have to remember them all. The first line just sets an environment variable to let the build environment know that we're running on a Pi 5. The next line then builds some default configuration based upon that fact. By then running make menu config, this will provide a menu-based system where I can select what extra modules I want to build into my kernel. The next line then builds the kernel. This line then installs all of the built modules into their destination directories. And finally, there are some bits of firmware that need to be copied into place before everything can work correctly. So now I'll go ahead and run this. Now you can see the menu system. The first thing I'm going to do is go into General Setup, and then I'm going to provide a customized piece of text that I can use to identify that it is my version of the kernel that's running. I then exit back to the top level. After this, I want to come down to the device drivers section. And then inside there, the section for wireless networks is network device support and then wireless. Now in here, there are drivers for all kinds of different network cards. In my case, I've got an Intel-based card. So in this section for all of the Intel devices, I come down to the latest Wi-Fi drivers for next-gen Wi-Fi, and I just select that. I happen to know that for my card, I need this NVMe firmware support, and now I have that configured, all I have to do is save my configuration and then exit back out. Now the kernel build will actually begin. This is going to take a fair amount of time. It can take around 45 minutes to build. So we'll just leave that going and come back when it's all finished. Now everything is built, we're nearly ready to go. However, what I do want to do is make sure that the drivers don't load at boot time. If there is any problem with it, I want to make sure that I can debug that. So what I'm going to do is create what's called a blacklist file in order to prevent the drivers being loaded at boot time. To do that, I just have to create this file. Now I have this, I just have to save out the file, and now I'm ready to reboot. Now the Pi is rebooted, and I've just started up a browser here so that I can get a baseline of where my Wi-Fi speed sits right now just by default. Okay, as a baseline that's not too bad. 95 down, 91 up, I can live with that. Now in the terminal window on the right, what I want to do is keep an eye on the debug message log. You can do that with this command here. This file will now just update in real time. Over in the left-hand terminal window, I'm now going to try loading the drivers for the wireless network card. And this has actually failed. You can see that there's an awful lot of debug message that has appeared in the right-hand window. And in the left-hand window, if I try to bring up the list of all of the network devices on the box, it'll only show the default ones. So initially, it looks like this network card won't work with our Pi 5. However, I'm going to reboot again and then do something a little bit different because there is some very strange behavior. Okay, now I've rebooted again and I'm going to bring up that same debug message log. Now this time, rather than loading the IWL Wi-Fi driver, I'm just going to load the IWL NVM driver. This is like the lower level driver that the network card uses. And again, that's failing, but I'm just going to let this fail and exhaust all of its retries. Okay, now all of the retries have been exhausted, what I'm going to do next is actually uninstall the driver. And now I'm going to try installing the driver again. And what's really strange is that this time it's actually worked. And now, if I bring up a list of all of the network devices on the box, you can see I've got one called WLAN 1 at the bottom, and this is my Wi-Fi 6 card. So now, what I'm going to do is I'm going to go into my network settings off camera here because I want to keep my network IDs private, and I'm actually going to connect to my Wi-Fi 6 network. Now I'm connected to my Wi-Fi 6 network, I'm going to run speed test again, and let's see what I read this time. As you can see from that, I'm now getting connectivity that's over 4 times faster than what I had previously just using the Raspberry Pi's built-in Wi-Fi card. So this is a gigantic win. Sure, there seems to be a bit of a problem with the drivers that are built into the kernel, and they don't seem to work first time. There is definitely some work required there, but these drivers do run. That's really impressive. So this is really good. I've now tried a USB controller card and a Wi-Fi 6 card, and both, with a little bit of playing around, have worked. Now let's try something a little bit more challenging, an NVIDIA graphics card. Now, I'm not going to be trying any kind of 4090 or anything like that that's silly. I've got a really old NVIDIA graphics card here, a GT210. Now this thing's ancient. It will provide a 1080p signal at 60 frames a second if it works, but there's absolutely no guarantees here. However, let's just stick it in the Pi and see what happens. Okay, now we've got our graphics card plugged into our Raspberry Pi, and by default, it's not doing very much at all. We can see it's detected by the system by running lspci-k, but you can also see that no drivers are loaded. I've doubled down on this by creating 2 new blacklist files, and these will ensure that the NVIDIA drivers can't load at all. Now there are 2 options for NVIDIA drivers on a Linux system. There are the drivers that NVIDIA provide themselves, and these are just called NVIDIA. And then there's another set of drivers, and this is an open source implementation of the NVIDIA drivers, called Nouveau. And I'm making sure that neither can load right now. Now, before we can do anything else, we first off need to actually install the NVIDIA drivers. And there are indeed NVIDIA drivers available. You can see the NVIDIA ones here, and the Nouveau ones here. Now let's see if this is enough in order to get our graphics card running. Okay, so I've experienced some issues here installing the NVIDIA drivers. The Nouveau drivers seem to have installed okay, but the NVIDIA ones have had trouble. And that's not that surprising really. However, let's reboot and see how we get on with the Nouveau drivers. Okay, so same as last time, I'm going to first off just start tailing the dmessage file. And now in the other window, I'll try to load up the Nouveau driver for the NVIDIA card. Okay, so that's failing, saying that the module doesn't exist. Maybe I need to do another kernel rebuild. Let's go and take a look at the menu and see what modules are available there. Okay, now we're back in the menu configuration for the kernel. Let's go back into device drivers and this time to the GPU drivers. Okay, here we can see there is a section for Nouveau drivers. Let's enable that. And now this will go ahead and rebuild the kernel again. Okay, now the kernel's rebuilt again. I'm going to do one more reboot and then we'll see what happens. Now we're rebooted. Once again, I'm going to try to tell the message log and then load up the Nouveau driver. And yeah, this has failed, just saying unknown chipset. So no joy there with this particular graphics card. Let's just make absolutely sure just by checking that there's no HDMI output being received. And yes, I've got another capture device that would be showing up on the right hand side of your screen here, but there's absolutely nothing. So we're getting nothing out of that graphics card right now. So there we go. Everything with our little adventures with PCI Express on the Raspberry Pi 5 has been a little bit of a mixed bag. The USB card worked perfectly first time. The network card did work, but we had a bit of trouble getting it going. And then with the NVIDIA graphics card, no joy at all. Now off camera, I did also try out an old AMD Radeon 6450 and a Radeon R7 240. However, neither gave me a result. The closest I came was a vague blue fuzzy screen at one point, but it was just snowy. There was no detail on there at all. And that seemed to be a fluke. Most of the time, I was just getting bar errors being reported within the log file. So I think it's going to be a while before we can get any kind of graphics cards running on the Pi 5 kind of natively like this. Clearly, the kernel for the Raspberry Pi 5 still needs a bit of work before we can really start using PCI Express properly. And I suppose that's no real surprise given that there aren't really any peripherals out there that natively allow us to plug in PCI devices. I've kind of hacked this one together, and I'm surprised at how effective it's been. But the trouble that I've had with it probably shows why manufacturers are still a little bit slow to release PCI Express devices for the Pi 5. However, I'm sure that this is a space that's going to evolve really quite quickly. But that's it for this video. Once again, if you like what you see, please click that thumbs up button, subscribe to see more, and hit that notification bell so you can be told when I put another video out. Have you tried connecting PCI Express devices to your Raspberry Pi? What kind of experience have you had? Please let me know in the comment section down below. And once again, if you've got any ideas for projects that you'd like to see me do in the future, let me know in there. But that's it for now. Thanks ever so much for watching till the end, and until next time, bye for now.